In this video, I'm going to do an example of a word problem that you'll definitely see on multiple occasions, where you have to calculate empirical and or molecular formulas for a compound. So if you're asked to calculate the molecular formula with percent compositions, which is what we're going to be using here, you need to calculate the empirical formula first. So I'm just going to do an example where we do the empirical formula and then keep it going to the next steps that allow you to figure out the molecular formula as well. So the problem is going to say a compound with a molar mass of 60.10 grams per mole and the following percent compositions let's see, so we've got carbon 39 point, oops, this is supposed to be a decimal there, my apologies, 39.97, hydrogen equals 13.41, and nitrogen equals 46.62%. Okay, and again, what I'm looking for here is the molecular formula of this compound. Now, what these percent compositions are, what that means is that you have a sample, and you analyze the sample, and you can get the percent of that sample from each element. So what it's saying is that from the sample that you analyzed, exactly 39.97% of the mass from it came from carbon, 13.41% of the mass came from hydrogen, and 46.62% came from nitrogen. Again, so these are basically mass percents. Right? So again, we are looking for the molecular formula, but first we have to figure out the empirical formula. So the first step for that, you assume a 100-gram sample. Now, why do we do that? So, for a problem like this, you assume that the sample is uniform, that it's the same exact composition throughout. So, it doesn't actually matter how much of the sample we have. It's not going to change these percent compositions, right? It's not going to change these mass percents. So, we say that we assume a 100-gram sample. And the reason why is because what is 39.97% of 100 grams? It's 39.97 grams. 13.41% of 100 grams is 13.41 grams. So as you see, assuming a 100-gram sample, it just allows us to change the units from percent to grams, which is something much more manageable in calculations. So carbon now becomes 39.97 grams. Hydrogen becomes 13.41 grams, and nitrogen becomes 46.62 grams. Alright, so in the second step, we now have to convert that to moles. So that's actually why we got it into grams, because we need to figure out the mole-to-mole ratios. Because if you recall, the subscripts for all the atoms in a molecule, the subscripts kind of just tell you the mole-to-mole ratios of each atom within that molecule. And that's basically what we need to figure out in order to figure out the molecular formula. So we had to get these into moles, and that's what we're going to do now. So for each one, so carbon, let's say hydrogen, and nitrogen, we're going to take the mass that we now got in step 1, and we're going to use each element's respective molar mass. So here, again, we have to put grams in the denominator to cancel out the grams that we are starting with. That's going to give us 3.3278 moles of carbon. Hydrogen, 13.41. And this is, I'm going to say, 1 mole, 1.008 grams. It's going to be 13.3036 moles of hydrogen. And for nitrogen, we've got 46.62. That is 1 mole on top and 14 grams on bottom, which gives us 3.3141 moles. Alright, so now step 3. Divide all mole values by lowest from step 2. So what does that mean? Well, we have to look at all of the mole values that you just calculated, and you have to figure out which one of these is the lowest. So, as you can see, in this case, that is the moles of nitrogen. That's the lowest of these 3 values. And so now that means we have to divide each one of these by the moles of nitrogen. Why do we do that? Well, again, right now we're trying to figure out the empirical formula. So this is going to guarantee that the lowest number of moles. So we're going to get ratios from these, and it's going to guarantee that the ratio for the smallest amount of moles is 1, which will inform us about what our you'll see after we do this math. It'll inform us about what our empirical formula is, right? So for carbon, we've got 3.3278 divided by, remember, the moles of nitrogen, which happen to be the lowest one here, moles, equals 1.004. For hydrogen, we've got 13.3036 divided by, once again, the lowest of the 3. That gives us 4.014. And of course, since we are dividing by nitrogen, or nitrogen's number of moles, anything divided by itself is just going to be 1. Oops, 3141 equals 1. Alright. So, sorry, these are kind of a little off-kilter, off-centered, but those 3 numbers, those are our molar ratios for the empirical formula. Now, if you see something like these 2 numbers, where they're just slightly off of a whole number, you can just round to that nearest whole number. So this is 1, and this is 4. If you see something like 1.5, for instance, something that you can easily multiply by all of these numbers. So let's say we got 1, 1.5, and 1. If you multiply by 2, the 1.5 becomes 3, which is a whole number. And so you'd have to multiply each of these by 2, and you get 2, 3, and 2. And that would actually be your empirical formula. So if you get something that can easily be multiplied by 2 or 3 to get all of them into a whole number, do that. But in most cases, you'll get something that is just slightly off of a whole number, and you can easily round to that whole number. Right? So that means that these are the subscripts for each of their respective elements in the empirical formula. So the empirical formula of this compound is CH4N. Right? So if we're just looking for the empirical formula, that would be it. That would be our answer. Since we're looking for the molecular formula, there's just a little bit more that we need to do. So we know that from the problem, the molar mass of the entire compound is 60.10 grams per mole. We need to figure out how many of the empirical formula molecules would fit into the molecular formula. So the way we do that is we take the molar mass, the actual molar mass of the compound, so we'll say 60.10, and we divide by the molar mass of the empirical formula. So let's also say molar mass of the compound divided by the molar mass. Let me make sure this is on the screen for you. Molar mass of the empirical formula. So you can just add this up from the periodic table, but for right now, I'll do that for you. It's 30.05. And so when you do that division, we get an answer of 2. What does that mean? That means that to convert this to your molecular formula, you need to multiply each subscript by 2. So to get to the molecular formula, C becomes C2, H4 becomes H8, and N becomes N2. And that is your final answer.